All right, the next thing it asks is it tells you after 10 seconds we are 1 foot above the equilibrium, and this is the high point in the cycle. So we have some sine or cosine curve, and we're at the peak. And they want you to find the initial conditions, y of 0 and y prime of 0. So what they give you, this is given, this is y of 10, and it's 1. And we know it's the high point, which we'll use somehow. Okay, and then we have this from last time. So if you didn't do the actual work of solving the differential equation, you just use these W and T formulas, you're just going to have to do that and at least get to this point. Okay, and so before we deal with this weird high point thing, let's try to figure out what they're actually asking. So they're asking for y of 0. So if we put in 0 into this equation, we have cosine of 0 is 1, so this is a, and then sine of 0 is 0, so we have plus b times 0. So y of 0 is just a. And then we need to take a derivative. So let's take a derivative of that function. We get 4 root 13 from the chain rule. Derivative of cosine is negative sine, so we get a negative a sine 4 root 13 t plus, and then we have another chain rule, so we'll get another 4 root 13 b, and then derivative of sine is cosine 4 root 13 t. Sorry, that's y prime of t, and then y prime of 0 would be putting in 0 for t. Sine of 0 is 0, so that whole thing is 0, and then cosine of 0 is 1, so we have 4 root 13 b times 1. Okay, so if we were to find a and b, we could finish the problem and we'd be done. So we need to find a and b with a different set of initial conditions, and they give us y of 10 is 1. There only seems to be 1 point. That doesn't seem to be enough to find 2 pieces of information. So we must use this high point thing somehow. The natural thing to do would be to go 1 period along. So we know from last time that the period is pi over 2 root 13. So maybe I could put in 10. I could find y of 10 is 1, and then y of 10 plus pi over 2 root 13 is 1. It turns out this doesn't give you any extra information, because then this just gives you, what you're going to be doing is you're going to be adding 2 pi inside of here, and we already know that cosine of something plus 2 pi is the same as cosine of the original something, and same with sine of something plus 2 pi. So that gives you nothing. So we can actually be clever, though. We can go either half a period or a quarter period. I'm going to do quarter period. So walk 1/4 period. So what's happening here is we have, here's time 10, we're at 1, and then we're going to be going, I tried to use this point here, and it didn't work. But what I'm going to use instead is this point. This is a whole period. I could use this point too. I'm going to use this one because 0 is easier to deal with than -1. The bottom would be -1, so you could certainly use that. I'm going to go to 0. So walk 1/4 period over, and I'm going to end at 0. So y of 10 plus 1/4 of this, so pi over 8 root 13, will be 0. And these 2 pieces of information are what I'm going to use to solve for a and b. Okay, so I put that all into my solution, my general solution to the differential equation. So y of 10 is a cosine 40 root 13 plus b sine 40 root 13, and we're told that is equal to 1. And then I'm going to put 10 plus pi over 8 root 13 in. So y of 10 plus pi over 8 root 13. It's going to be a little bit messy. This is a cosine 40 root 13, and I'm distributing the 4 root 13 in as I go along, plus pi over 2, plus b sine 40 root 13 plus pi over 2. Okay, I have a couple ways of doing this. Remember I told you to memorize the formulas for cosine of a plus b and sine of a plus b. So you could use those and figure out, expand this. Cosine and sine of pi over 2 are both easy numbers, so you'll be left with something nice. Or I can think about, here's just another way of thinking about sine and cosine. I'm looking at, let's see, cosine of theta, right? This is the point on the unit circle. Cosine theta, sine theta. And I want to add pi over 2 to it. So I'm going to go here. So if this is the point A, comma B, x coordinate is A. It looks like the y coordinate is now A if I add pi over 2. And y coordinate was B. It looks like the x coordinate is now negative B. So from this picture, I claim that cosine of theta plus pi over 2 is negative b, so negative sine theta. And then sine of theta plus pi over 2 is equal to a, so equals cosine theta. And I could get these results from these expansion formulas that you may have taken my advice and memorized, or maybe not, or I can get it pictorially. So let's see, cosine of theta plus pi over 2 is negative sine theta. So I have negative a sine of theta, in this case, is 40 root 13. And then I have sine of theta plus pi over 2 is cosine theta. So this is plus b cosine 40 root 13. And this is supposed to be 0. Okay, so now I have equation 1 and equation 2, and I'm going to solve this system of equations for a and b. It's a little bit messy. My best method here is going to be elimination. So what I'm going to do is I'm going to multiply both sides of the first equation by sine of 40 root 13. I'm going to multiply both sides of the second equation by cosine of 40 root 13. And I will notice that my a terms, when I add them together, are going to cancel. So let's write that down. Make sure I'm not making that up. So let's see, get this in the frame. So I'm going to take equation 1 multiplied by sine of 40 root 13. What happens there? Then I get a cosine 40 root 13 sine 40 root 13 plus b, and then this is going to be, it already has a sine 40 root 13, so this will be sine squared 40 root 13 equals 1 times sine 40 root 13, so just sine 40 root 13. And then I'm going to take equation 2 and multiply by cosine 40 root 13. I'm going to write my b term first so that I don't have a negative out in front, so I don't drop it on the next line. So cosine squared 40 root 13, but now my a's don't line up. It's okay, we'll live. We're going to multiply that by cosine 40 root 13 sine 40 root 13 equals 0 times cosine 40 root 13. Okay, so just 0. Okay, check that out, make sure that's right. And then now I'm going to call this equation 3 and equation 4. I'm going to do equation 3 plus equation 4. The a terms will cancel, right? I have a times the ugly mess. Here I have negative a times same ugly mess. So those will cancel. And this is actually really, really nice. I get b sine squared 40 root 13. We got a nice thing out of the mess. Plus b cosine squared 40 root 13 equals sine 40 root 13 plus 0, so sine 40 root 13. And now on the left, if I factor out a b, I have a very nice thing, sine squared 40 root 13 plus cosine squared 40 root 13, which is 1. So I just have b equals sine of 40 root 13. Okay, I'm most of the way there. Now I just need to find a. I think the easiest way to do that is to go to equation 2, substitute b into equation 2. So I'm going to have, I'm going to write the second term first again so that I don't have a negative in front. 40 root 13 cosine 40 root 13 minus a sine 40 root 13 equals 0. Sine of 40 root 13 is certainly not 0, so I can divide both sides by that, so that will get divided out. 0 divided by that is 0. So then a is cosine 40 root 13. And if we were really smart and really lucky, we might have been able to guess that at the beginning. If we looked at equation 1, then if I plug in a and b, these values, I get cosine squared 40 root 13 plus sine squared 40 root 13 is 1. Then plugging in and making it work doesn't guarantee that those are the values. You'd have to plug into the second one too, but that's kind of cute. Okay, now that I have those, I can go back and see what I was looking for. So I wanted y of 0 and y prime of 0. So y of 0 is a, which is cosine 40 root 13. And when you calculate these, make sure you're in radians. So either your calculator's in radian mode. Sometimes I just type it into the internet now. The internet defaults to degrees sometimes, depending on what website you're on. So be careful. And then y prime of 0 is just 4 root 13 times b. So 4 root 13 sine 40 root 13. And WebAssign wants some ugly decimal for both of those. That's how you get that.